All right, let's dive in. We're going to crack the code on one of the most intimidating topics for developers, system design. And if you've ever felt that pit in your stomach when this topic comes up in an interview, well, you know exactly what I'm talking about. You are definitely not alone.
And yeah, that feeling, it's super common. The pressure to just memorize patterns for designing a chat app or a streaming service or URL shortener, it often leads to failure. You study all the diagrams, you memorize the tech, and then the interviewer throws you a curveball, something just a little bit different, and boom, the whole house of cards comes tumbling down.
Okay, so if just memorizing stuff is a trap, then what is the answer? Well, the secret isn't about knowing more technologies. It's about a fundamental shift in how you think, and it all starts with the very first question you ask. So let's dig into this memorization trap a little more. A lot of engineers, especially when they're prepping for interviews, they approach system design like a test you can just cram for. They try to memorize these blueprints for common problems, but that strategy is super brittle. It fails the moment the problem deviates from the script, right? And this gets at a really common mental trap. When you look at a finished system diagram for something like Netflix, it seems so logical, almost obvious. But that's just hindsight bias, isn't it? It completely skips over the most critical part, the messy, uncertain journey of actually getting there. That journey, that's what interviewers are really testing.
Okay, so this brings us to the most important point of all. The very first step in any system design isn't about technology or databases. It's about asking one simple, super powerful question. Why? Seriously, why are we building this? And who are we building it for?
And this, my friends, is called scoping. It is the single most overlooked but most important part of system design. It's how you stop scope creep, where a simple feature request balloons into this monster project. Think of it like drawing a fence around your backyard. It tells you exactly what you're responsible for building, and just as important, what you're not.
Okay, let's make this real. Imagine you're designing a pizza shop. Before you can build anything, you have to define the process. Take the order, roll the dough, add the toppings, bake it, and box it up. By breaking this simple process into these clear steps, you're defining the boundaries and the flow. You're scoping the problem. That's it. That's the heart of system thinking, right there.
All right, so once you know what you're building, you've got to face this fundamental law of engineering. It's a law that governs every single decision you're going to make from here on out.
I mean, you just can't have it all. Every choice, whether it's the database you pick or your caching strategy, it comes with a cost. That cost could be performance, it could be actual money, or it could be making the whole system way more complex. Your job, as the designer, is to understand and get really clear on those trade-offs.
And the CAP theorem is the perfect example of this in the wild. It's a cornerstone of distributed systems. And it basically says that because network connections can fail, that's what we call a partition, you are always forced to make a tough choice. And for most systems you'll ever build, that choice is between consistency and availability. So let's break that down. Are you building a bank where every single transaction has to be perfect? Well, then you have to choose consistency. But what if you're building a social media feed? It's way better for a user to see a slightly old post than a big scary error page, right? So there, you go with availability. And it's not always black and white. And your decision all goes back to that first step, scoping the problem.
Okay, theory is great, but now let's see how all this stuff actually applies in the real world. We're going to start with a simple service, and we're going to scale it up, step by step, to handle millions of users, making those trade-offs as we go.
Pretty much every app you've ever used started right here, a client. Your phone, your browser, talks to a server, which then reads from and writes to a database. It's simple, it's clean, it works, until it doesn't. And what's the problem? Well, if that one server or that one database goes down, the whole thing is toast. That's a single point of failure.
Okay, so to handle more users and, not have our site go down all the time, we add more servers. But now, how do we decide which server gets which request? We bring in a load balancer. It's basically a traffic cop sitting out in front of our servers and just spreading out all the incoming requests nice and evenly. This keeps any one server from getting totally overwhelmed. So the system keeps growing, and now our poor database is starting to sweat. It's becoming the bottleneck. This is where caching comes in, and honestly, it's like a superpower. By storing data that gets accessed all the time, like a popular user's profile, in a super fast in-memory store, we can serve it up instantly without ever having to bother the database.
Yeah, for any high-performance system, this is the mantra. Always be caching. You can stick caches in multiple places. on the client, near the servers, even right in front of the database. It's one of the absolute best tools you have for making things fast and taking the load off your other components.
But hey, even with all this clever caching, guess what? Your database is going to become a bottleneck again. So, what do? How do you scale the database itself? Well, the first step is partitioning. Think of it like a pizza party at one single house. All the pizzas are in the same building, right? But you put the pepperoni on one table and the veggie on another to keep things organized. It's all on one server, just split up logically.
But what happens when one house just isn't big enough for your party anymore? Well, that's when you shard. Sharding is like turning your pizza party into a full-on block party. The pepperoni pizza is at one house, the pineapple is at another house down the block. You're splitting the data physically across multiple machines. And this lets you scale out horizontally, like almost forever.
So why does any of this matter outside of a super stressful 60-minute interview? Because this way of thinking, this whole approach of scoping, making trade-offs, and scaling, it applies to literally everything.
What this is really about is developing system thinking. Yeah, it helps you build better products, for sure. But it also helps you work better with your team, because you actually get how your piece of the puzzle affects everyone else. It even helps you understand business constraints and navigate your own career more clearly.
Think about it. Your team, it's a system. Your company, that's a system too. An open source project you contribute to? Yep, also a system. The people who are most effective are the ones who can step back, see the whole forest, not just the trees, and really understand how their work fits into that bigger picture.
So I'll leave you with this question. The next time you're stuck on a problem, whether it's code or your career or anything else, just try to zoom out. Ask why. Figure out the boundaries. Think about the trade-offs. Because at the end of the day, recognizing the systems you're a part of, that's the very first step to really mastering them.